Okay, great. So hello everyone. For those who have joined us previously, good to have you. And for those who are new, very few people here today, welcome. This is our third session, a fourth session in the design mini-series, backend design patterns mini-series. And I'll just quickly introduce myself. Hi, I'm Prachi. I'm a senior software engineer at Metro Mile. As a part of Women Who Code, our mission here is to inspire women to excel in their careers and to support them in any way possible. Today's agenda is behavioral design patterns, which we'll look into a bit more. We still have two more sessions, which is anti-patterns, basically things not to do or practices that are not good. Right, so they are the opposite of design patterns. And the next session after that is interview questions. So we will actually look into design patterns and more design questions. We can solve some problems together and we can have like a proper discussion around how to solve design pattern questions in general. Moving forward, quick introduction. I do this with every session because sometimes folks are new, so, and also a good refresher. So backend engineering is everything that the front end doesn't see, right? The user doesn't see. The user doesn't see, right? So it's like everything behind the scenes, your microservices, your storage, your database, your server, a bunch of other stuff, right? So the whole goal for backend engineering is to design, build, and maintain server-side web applications or microservices and other systems. So some common concepts that are part of backend engineering is client-server architecture, APIs, microservices, database engineering, distributed systems, performance, availability monitoring, bunch of things, concepts and tools and tech stacks that go into what backend engineering is. If you talk about software design, basically we want to come up with like an architecture, define an architectural, a modular approach, define what the interfaces or interactions between systems would be, what the data flow looks like, right? Ideally, we are solving a problem, right? We already have a system, but it's not able to scale. So now it's a scale. The design problem here is for scalability. So we ideally want to design or redesign and solve a problem, or we are building something new and we want to design it well so that it scales. We are able to increase the performance. We are able to monitor it well, right? The data flow is very neat across the system. So some of the basic things we do when we think about software design is we think about what the input is, right? The input data and what the input endpoints look like, entry points look like. We think about output, we think about business rules, and we think about data schema and the data flow. Design patterns help us solve some of the common problems that we encounter when we are building products, when we are building systems. There are certain, these are like, you can understand design patterns as a set of best practices and templates, right, for some standard solutions or standard way of doing things. If you still talk about design, you can break it down into three different types. One is UI design, which looks into what the data visualization is and the presentation is to the customers, to the users, right? What your front end, how your front end is basically displaying the data. The data design is what is your data flow? How is it stored? How is it updated, right? What does your data schema look like, right? And process design is more like validations, data validations, manipulation of your data, a bit more about how are you storing your data, how are your systems monitored, availability, performance, bunch of different things. So design patterns, like I mentioned before, they are a set of template solutions that can be reused to reused or built on top, right? So like the main benefit of design patterns is like code maintainability and reusability, right? So if you have a problem and you want to design DoorDash, you don't know where to start. You don't even know what my first line of code should be. How can I even think about designing DoorDash, right? What would my code look like? Can I break down features of DoorDash into different, can I break them down, right, into different features, and how do I implement these features, right? How do I design them? So you can use different set of design patterns which will cater to each design problem that you have and solve it. You can adapt a template, and then you can build on top of it or extend it to meet your product or business needs, right? So for this mini series, we are looking into primarily Java design patterns, but these design patterns are common with .NET, Python, etc. So your underlying language can change, but the theory of it or the concepts remain pretty much similar. So here we also leverage object-oriented programming principles, which we'll go over quickly in a bit, to understand the code here and to understand the concept in a deeper level. Just to note, design patterns are not like a library or a framework which you can just like add it to your project and boom, there you go. Design patterns are like, these are proper theoretical solutions which you now need to adapt and implement to meet your needs in the code, in your product, in your software, in your microservice. So you adapt and then you improve upon it, right? The core idea of design patterns, one of the core ideas is also to understand the relationship between objects, data flow, and how to secure your code. And to the right, we see this is the breakdown of all the design patterns that we have in the object-oriented world, at least. We looked at creational, which was our first session in this mini series. We looked at creational design patterns. Then last time we looked at structural design patterns, and today we will look at 4 of the behavioral design patterns. Quickly go through what these mean. Creation design patterns focus more on how to initialize a class and how to instantiate objects, right? So creation of objects and instantiation of objects is what creational design patterns give us some template solutions about. This is different from the implementing system. You can create different objects, right? But these different objects can have a different behavior, or the implementation is a separate different logic in your code, which is different. Creation pattern just cares about different template solutions to create objects. Some of the examples are Singleton Factory Builder, which we looked at during the session, 2 sessions back, and some other are Abstract and Abstract Factory and Prototype. Structure is different in the sense that it focuses more on the class structure and composition, and it looks into basically creating relationships between large objects. Adapter design pattern, decorator, facade is what we looked at last time. Structure helps us basically reuse our code and like improve or extend our functionality. This also makes the code more maintainable. Today's session is about behavioral design patterns. They define the relationship and communication between different classes, and they also focus on the behavior or different objects within your system. Some of the behavioral design patterns are observer, strategy, iterator. 4 of them we are going to look at today. So Q&A time. Can you summarize in your own language what does a design pattern mean, or what is a creation design pattern? What's a structural design pattern? Can you think of like a real life example? It can be anything, tech related in your code that you saw, or anything otherwise as examples of design patterns.
Feel free to unmute and answer, and it's okay if it's wrong. It's just like it's okay. It's perfect.
Yeah, and you can also put in the chat. It's fine.
Or you can put it in the chat. That's fine as well.
I know we have a small room, so it's fine.
Anjana says design patterns are templates that can improve code maintainability and solve common problems.
Yeah, that's perfect.
Darcy says usable solution.
That's correct. All right. All correct answers. Yeah.
Can you think of examples that that Prachi mentioned in the previous events? Like an example of a creational or structural design.
Or if you remember from our previous sessions, that's also fine. Factory for creational. Yeah. Factory helps you create or objects out of the box. Similar configuration, yeah. Okay, I think we can move forward. Thanks for the answers. They are all correct. Okay, I think it's important to quickly revise some basic concepts of object-oriented programming, because when we look at the code, what is mentioned here is exactly what we'll see in the code. So it will be really easy for you to understand the flow and understand what we are doing, why we are doing, and the structure of it. So this is again a simplified version of what these concepts are. We did, if you look at the Creational Design Patterns YouTube video, you will see I have done a code demonstration of these concepts, so you can refer to that as well if you want to also do a revision with respect to what the code looks like here. Okay, inheritance is super. So inheritance basically helps us create subclasses which inherit the methods and attributes of superclasses. How we do that is using the super keyword in the constructor of the subclass and pass the attributes to the superclass. So basically think of an example, right? Like a fruit is a superclass and its subclasses are mango, apple, banana. Some basic properties of the fruit apply to all these three subclasses, right? Like the taste or the color or the name. And then these different subclasses can have their own extra set of behaviors and attributes that may not apply to every fruit, but they are custom to each subclass, right? Each fruit. So if you just define in the fruit class once certain attributes and certain behaviors, then you can just reuse those into all your subclasses. So you don't have to, you just have to define how they look like, but you don't have to rewrite that whole code, and you don't have to like replicate a lot of things, because inheritance helps you reuse and gain the attributes and properties of your superclass. Polymorphism is same method name but different behavior. So there are two ways we implement polymorphism. One is overloading, where it's the same method name but different parameters. So this can be in your same class, where let's say you have a fruit class, and maybe fruit class is not the best example, but you have a class where you have like same names, but depending on the parameters, so same method names, but the parameters would be different. And therefore, if you call a certain method, depending on what the parameters are, the count and the type, either of these methods will be called. Overriding is related to inheritance, where the method signature name and parameters are the same in subclass and superclass. So basically the subclass in this case will override the behavior of the superclass. Abstract class is we use the abstract keyword. So abstract classes have like concrete methods, and you can declare as well as define variables and methods. So the reason why class is called abstract, because in a normal class, you declare and then you define the behavior, whereas in abstract class you only declare. So let's say I say that I have a variable named fruit color, right? And then I have a method to calculate something, right? Or give me the fruit color. It can be, I can in my abstract class either define what that method behavior is, or I can just define that function. I can just declare that method or variable and not define what the behavior is. So any other concrete class that extends my abstract class will now override and define a behavior for that particular abstract method. Other concept here is objects that extend one class have the same or default behavior that can be overwritten, right? So let's look into an interface. interface only has like abstract methods in the sense that you just declare methods, you never define anything. And if you want to use an interface, you use the implements keyword, which is different from an abstract class or any other class in inheritance where you use an extends keyword. So polymorphic behavior, which we talked about, overriding, that implements or leverages the concept of interfaces. We'll look at the code and you'll understand this a bit more. Yeah, can you, we looked into some object-oriented concepts. Can you give examples, some real-life examples, or just define these in your own language? Like what's inheritance, what's polymorphism, what are abstract classes, interfaces? You can put in the chat.
I like to think about inheritance always like, think about you're inheriting so many of your qualities from your parents. That's like as simple as that.
Yeah.
So it's a parent-child relationship, and that's the similar terminologies we use in software as well. And that's very simple way to remember what inheritance is.
Yeah.
It's just everything that your parent has will, you will get everything that your parent has. And then you also have additional attributes that are of your own that your parents might not have.
Yeah.
So that's how it works.
Yeah.
So subclass, you are the subclass of your parent, and that subclass has more attributes.
That's correct. Yeah.
So Darcy says encapsulation. So that's when we allow fields to be set private.
Yep. Correct. Exactly. You're right. Yeah, there are more concepts. I've not covered them here because, again, focused on the code and focused on the session. Yeah, but Darcy, you're right. Encapsulation is not something we have here, and that's the right definition. Polymorphism, yep, that's correct.
With interfaces, I know this is true in like Python, but you can inherit multiple interfaces, but when you just are inheriting like one class, like you can only do that once if it's concrete, but then you can have multiple interfaces that you're inheriting. I don't know if that's also the case in Java.
Yeah, so Java doesn't allow like inheriting from two different classes. It doesn't allow that, but you can implement more interfaces. So that is correct. You can only always extend one class, right? So you can only be a subclass of one superclass.
And all these concepts are like the basic OOPS concept, like object-oriented programming concepts, but according to the languages, the implementations might differ. Like right. These are the generic ideas, but how inheritance works in Java versus works in Ruby might differ. Or how polymorphism is mostly the same across languages, but like certain languages will implement, say, abstract class. That might be a different way to implement that in Java versus Ruby.
Right.
So always keep that in mind.
Yeah, the idea of abstract versus concrete methods, right, and the behaviors might look slightly different in Java versus, let's say, C# or let's say Python. All correct answers, Darcy. Thank you. We can move forward. Okay, so the first behavioral design pattern is chain of responsibility. So here, think about this as like a messenger, right? Like you have the sender object and you have this receiver object. And for your object or your data to be sent by the object and to be received by the receiver, we have there's different other intermediary objects that actually pass the message or pass the data, right? So this becomes like a chain of responsibility for passing that data, passing that message, right? So this avoids like a tight coupling between sender and a receiver, right? So if the sender changes for whatever reason, the receiver doesn't break because the sender ensures that these intermediary objects are responsible for still passing the data, right? Like if the sender was sending one package, now the sender has expanded to do 10 other different things, but it's not breaking the receiver, right? It's still, if the contract of sending and receiving is through this chain, then that message will still be sent and it won't break that chain of responsibility. So like I said, it links different objects to form somewhat a chain. Yeah, so once the object handles a particular request, like a message data point, it will process it and just send it to the next object available in the chain. And how are these objects determined? They are determined somewhat at runtime. So these intermediary objects are called handlers, and they are determined at runtime. So handler here becomes like an interface that receives and sends it, or an object that receives and sends it to the next handler in that given chain that is being defined. So yeah, yeah. If you think about like an example, right? Like package, right? Like we have to send a package from, let's say, Arizona to New York, right? You send from the source, and like a package handler in Arizona handles it to, let's say, California, and then handles it to New York, right? So then these states or the handling systems between your source and destination become your handlers, right? Who are just like shipping the package, processing it, and then moving forward to the next destination. That's their next object is there in the chain of the shipping flow, right? So we can quickly look at the code here. Let me see if we can see. I'll share my screen. Can you see the screen? I don't know. Or should I do a new share?
No, we can just, can you increase the font a little bit?
Yeah, I wanted to ask that. Is this better?
Mm-hmm.
Okay, great. Okay, so if you look at chain of responsibility here, right? I have this initializer class. What I'm doing is, as an example, a very, very basic example of this design pattern. I am sending my package from some source to Arizona, to California, to New York, and then my destination of my package is some other state. Right now, I'm just focused on these three things, just to demonstrate what the chain of responsibility here is. Sorry.
So Darcy mentioned there's a presentation mode if you're not using the side panel.
I have not done that presentation mode. Let's see, should be in view probably.
Yep. Do you know, Darcy, where it is?
Oh yeah, okay, found it. Let's try
for the as well. Yeah, that's
is this better? Is this okay?
Then you'll have to make sure that you open the files manually.
Yeah,
because you don't have.
Yeah,
awesome.
Yeah. Okay. Well, I'll try my best to go back and forth between files, but let's try this because this is better for you viewers. Okay. So yeah. So this is what is my chain right now, and let's see how I can implement the chain, right? So I have defined like a package class. Right now it just has a package ID. I can add a bunch of other details in it, like the weight and the name, whatever. Just to keep it simple, I have just added the ID, and then we have the constructor, and then we have the get and set package methods, right? If can I go back? Can I go? You cannot go back, so probably doesn't. This might not be the best. I need to exit. Sorry about that. I need to open these other files. Let me increase the font. Let's do that. Is this better?
Yep. Yeah, if you're referring to the folders sidebar, then it's okay to have this way. Like if you're going back to that.
Yeah, I have to go back and forth between files. So that's why presentation mode is probably not the best, but I'll figure this out if there's a better way to do this before our next session. Yeah, so I just define the package class, something very basic. So in my initializer, I create the package that I want to ship, right, in this particular path. And then the first thing I do then is I create the interface here. So this is my handler interface. What this tells me is that every handler in my chain of responsibility, in that shipping chain, has all these three qualities. Okay, has all these three behaviors. So what they'll do is they'll make sure that they are sending the package to the next shipping handler, the next immediate shipping handler in the chain, right? You can also get the shipping status from this handler, right? Once this handler got the package, now they will also tell us what the status of the package is, right? So we need to know that. And I've also given like a name for every shipping handler. So every shipping handler is responsible for what their name is, at least in this example. This is helping me print the results in a better way. So I've just added this, right? So these behaviors will apply to all the handlers, but how they are implemented might look slightly different for each handler, right? So this is the use of interface where we have just declared, but we have not actually defined the behaviors here for handler. Then what I've created is I've created like 3 different handlers. This is an Arizona shipping handler. So in context here, my package is now delivered to the state of some USPS in Arizona. It's handling it, and then it's going to process it to the next destination. The next handler or destination in my chain, right? So the name of my Arizona shipping handler is this, right? And all it cares about is the next shipment handler that it needs to send the package to. So this is my data points in this particular class, right? And if you see, it implements shipping handler, therefore it has to override and implement or define its own behavior to each of these 3 methods, which are common to all shipping handlers, right? So what it will make sure is that it knows and sets the next shipping handler in the chain, and it will also give me the status. So for Arizona, what our status here is that it has successfully shipped a package with ID to the next shipping handler in the chain. And this method is just to return the name of this handler. The next one is California. It has similar data points. It is implementing all the same methods. The name here is different. The next shipping handler is what is going to set. And in California, there was a delivery exception, right? But then at this handler, there was a second attempt, and then California was able to ship the package successfully to the next one, right? So that's slightly different here, the behavior of this handler or the status than what we saw in Arizona. And with New York, it still has a name, right? Similar data points, similar behavior. But with New York, it's like, oh, I successfully delivered the package to the destination, and this delivery from the sender to the receiver is not complete. So its status for the package is different from the other handlers in the chain, right? So now when I look at initializing this is my flow. I've created a package. I have created all these different instances of the handlers. Anjana, you have a question?
Sorry, yeah, I don't mean to interrupt you if you wanted to finish that thought. Basically, my question was kind of along the lines of the different statuses, just so I understand like the business logic of like why you would have different statuses. Like, should that be like, is that something that's like hard coded for the example, or like, yeah. I guess I'm trying to just map to like what the need would be or what a use case would be in this situation.
Right. So I was going to talk about it after
Awesome.
I'm done. Yeah, that's a good question. Give me a couple of minutes and I'll answer that. But thank you for asking. Yeah. So quickly, I've been clear instances of these different handlers. So they are now in my system. I'm making sure that when Arizona sends this package, when it gets this package, it sends it to California. When California gets this package, it sends to the next handler, which is New York. And at the end, what I'm doing is I'm just like asking each handler to tell me what the status of their the shipping is, right, in this case. So if I just quickly run this code, it should be able to, the system is a bit slow, but it should pick up. Yeah. So Arizona shipping handler has successfully shipped a package with this ID to California. California shipping handler has had a delivery exception on so-and-so date, but then we did a second attempt and it shipped this package to New York, and the New York successfully delivered that package to the destination address. So you see, this is how we have like implemented like a chain of responsibility pattern here, that between sender and destination and receiver, there was this, we created this chain of objects, and on runtime, I decided what the next object in my chain is and what the status of each of these handlers is. So to your question about the status here, right? So this is just as an example, very simple, hard-coded, just for you to understand how this works. In real life, this can be very, very different in the sense that each handler can do a lot of different processing on the data and send it forward. That is a very real possibility. Or something like this, where all it does is it just like gets a package, does the basic validation checks, and just like moves the package forward in the chain, right? So here I have just hard-coded it for simplicity, but what the handler behavior is for that object or that data point can be very different. It can be very focused on the business logic. So we have that freedom here, and that's why we have that interface here, because now we can define any number of handlers we have in the system. They have somewhat similar behavior, which defines them as a handler, but how these behaviors are implemented can be different for each of these handlers in the chain. Does that answer a question?
Yes, it does. Thank you.
Okay, great. Yeah, I'm just creating something very simple because real life examples can be complicated and I don't want to confuse, right? So we start small, we understand something very basic, it's working. Now you can feel free to get this code, it's on GitHub, feel free to download this code and just play with it, mess with it, do something else, try something else, create maybe another handler and maybe a very different behavior, and see how you can implement this. Do we have any questions? This is just like a UML diagram, just to understand one example or one. It's more like a template for what this design pattern is. Can you think of a real life example? Can you define chain of responsibility design pattern in a few lines? We have a quiet room.
Like a use case, or
yeah, can you think of some real life example of or a use case, sure, of this design pattern? Yeah, that's correct. Cool.
Sorry, could a potential use case be like if you're building an application and you get a request from like a client, and like depending like maybe you have like a routing sort of proxy that like depending on what the request is like maps it, like a load balancer? Is that something that would use a handler?
Yeah.
Okay.
That's when you think about design, system design, that is something comparable. Yes, like a proxy, right? Proxies are good examples of chain of responsibility. All they do, routers, right? All they do is just move the package forward in the network, right? At the very basic. Again, I'm oversimplifying. But yeah, it's just a chain of passing the data or message passing. It's a good example of a chain of responsibility. We can move forward. The next one is iterator design pattern. This is, I think, it should be very familiar. At least if you have done even a little bit of coding, this is probably one of the most known design patterns that we have. So basically, iterator helps you traverse through a collection of objects, right, in a specific manner, right? So it's like a cursor. You go through your cursor goes through each object in that collection, right? You access the elements without revealing what that implementation looks like. So you don't really reveal how are we accessing. It's just like you define or you rather pick the manner in which you want to traverse through a collection, and the iterator will do that for you, right, without telling you how exactly the traversing looks like. So again, we'll use interface with certain methods to iterate over a collection of any type, right, like an array list or a hash map, sorry, a hash set, something like that, right? Different simultaneous iterations are also possible. So like one way or bidirectional, right? From the top to bottom, like an ascending order or a descending order. Concrete iterators, they implement this above iterator interface, and also they track the position of the cursor or the current position in the traversal. And then we'll use an aggregator object, which basically helps create like an iterator. And the concrete aggregator will be an instance of this aggregator and implement the concrete iterator. So one example would be like dictionary of names, right? Like you can search alphabetically, you can search from the top to or you can begin from the end, right? So just you're traversing through a list of words here, right? That's some of the most basic examples of traversal in general through a collection of data points. If we look at the code, yeah, so here I have, let me step back a bit. I have an order object here. What I have in the order object is just the order ID and name, something very basic, a constructor, and then get and set methods. So this is what my domain object looks like here, right? Just for context. And then I have two things here. One is the let me step back a bit. Yeah, so the first thing is the order iterator. So this is a basic behavior of what an iterator for an order should look like. So what this iterator will do is, as we talked about earlier, it will keep a track of what the next position is in the iteration, and it will keep a link. It will get us the next. It will actually get us the next order in the list of orders, right? So we have an order iterator, and this is what its behavior is. And the second one is interfaces order management. So this will actually just given a list of orders, I want to iterate through this list of orders using this order iterator that I have created. So I can have another kind of order iterator too, and it may have slightly different behavior. So if I use a different type of order iterator for this list, then I can iterate through that in a different manner, right? What my other order iterator is defining, what the traversal process there is. So we have defined our core iterator, and we are making sure that our list of orders uses that particular order iterator that we for traversal for this list of orders. Now, if I look at the iterator, let me look at this first. So now I have my order management implementation class. It's implementing that order management. So what it's doing is it has to therefore override. So my order management, what it does, it gets the list of orders in a given specific iterator, in a given specific traversal format. And how this is implemented, now we have this aggregator, right? This is basically a creator iterator. So this is where we define what that iteration actually looks like, right? What that traversal actually looks like. So what we'll take here is a list, and we will have an index here, something to begin with, which we maintain at that object level, right? Therefore, it's at the class level here. It's implementing our iterator, right? This interface. So now we define what the behavior of these two functionalities in our iterator should be. So if you look here, the constructor just takes the list of orders, and what my has next does is make sure that the value of the index is less than the order, than the size of the list of orders, right? So then we know that there is a next order in the list. We have not reached the end of the list, and therefore there is no order. So this helps to maintain that cursor or that index in your list. And what next does is this has to give us the next order in the list as we traverse, right? So what it does is make sure that there is a next item still, that we have not reached the end of the list, right? And we make sure that the index is still less than the size. So probably not, yeah, probably this is repeated, but yeah. What now we do is we get, based on where the index is, we get that item from the list at that particular index. And if you see here, I'm also increasing the index. So the next time when we traverse to this, the index will be +1. So we will get the next item or the next order in the list, right? And then I'm just printing the details, because now I have the next order in the list, and I'm just like printing the order ID and the details, and I'm returning the order. So it's fairly simple an implementation. And if I look at the initializer, what I've done here is I've created a list of orders with some ID, and this is the list of items in my order. Note that this is all string. Real life example will be very different. There will be an item class which will define each item, and then here it will be a list of items, which is like item here is Big Mac, fries, chicken McNuggets, etc. Right? And there'll be much more qualities. This is just a very simple implementation of what an order looks like. So now what I do is I initialize my iterator, and then I create a list of orders. And then in my order management implementation, what I'm doing is, given my list of orders, this is the iterator that I'm going to use. And can you traverse to that iterator? So I actually call the iterator here, right? So this is the iterator that I defined. And as I do has next, I'm just getting the next iterator, sorry, the next item in the list of orders. So if I run this code, you'll understand that how I have called the iterator and these functions, right? So if you see, here is my order list. It's just printing the order ID and the order details for every order in my list. So here, if you see, it's right now in the ascending order, and that's what I have defined. If my iterator here would want to start with the last index and then go back towards, like, if this was minus, then I would start from the last index and then go to the very first item in the list, right? So from the last item, so it would be a descending order in that case. So this is how I have implemented one kind of traversal strategy here for this iterator for a list of orders. Yeah, and pretty much every iterator has next, just to check that we have a next item in the list, and then if you have, then go get it, right? And because this next also here, the implementation prints, therefore you see that I got the next order, and then I'm just printing it right here. I could have moved this, and I could have moved this to here. Once I could have done like order, right? Order, and then get the order, and then just do the printing here. It's the same thing. Do we have any questions? can you think about like some real life example of iterator design pattern or any other use case? So if you see here, I had my order iterator, and then I created the, and then here I have my actual implementation of the iterator, and this is my, this is the other order management, and this is where I have basically iterating over list of orders.
I guess like any sort of case where you have, I guess like different business needs to order things differently or iterate through things differently. Like maybe like an example I can think of off the top of my head is like, if you want to, maybe you have like a person class and then a student class, and you want to like order the students by like ranking, but then your person class, you want to order them by like age. You'd have like an iterator that, or you'd have an interface for iterator, and then like you'd override it for like person, and you'd override it for student.
Yeah, that's a good example. Just iteration in general, right? You have a list of collections, or you have a collection. Sorry, you have different kinds of collection, a list or a set or something. You need to iterate to that, traverse to that, right? To get the data and then process the data, right? So basic iteration applies to any collection of data points. I think we can move on to the next one. We have this one and a strategy. So observer. So observer is basically defines a one-on-one coupling or dependency between objects. What this means is that if one object, the state of one object changes, all the objects that care about the state of this one object will be notified, right? So they are. You can think about it as like a publish subscribe model, where one object publishes, and all the other objects that are subscribed to this object will get any kind of notifications or updates or state change notifications, right? So objects can have like the same or different, but objects can be the same or different, but they will implement the same observer interface, right? So what the observer, what this publish subscribe process looks like, that will be common to all the objects that are subscribed, right? So we use like few different objects here. One is observable. The object's state change is of interest, right? So observable is the object whose state is changing, and whose state is the point of interest here. And observers are all these registered objects that are notified when an observable state is changed. Common functionalities is like, some of the common functionalities we do here is we add a new observer, we remove a new observer, and we have like a hash change method which checks from time to time, like poking, like from time to time, has the observable state changed, has it not, and then an update which actually updates all the observers with whatever the state change for that observable is. Something like some examples here, real life examples could be like marketing emails, right? Like you whenever you sign up to a website or an account, they ask you, would you care about marketing updates? If they do have an update, you get an email, right? Or if there are new product notifications, you already enrolled for them, so you become the observer here, your email address, and you will get notified, right? Kafka is another real life example where it's a pub sub process here. Things like, like you subscribe to like some news updates. So once there is an update, in your phone app, you will get updates, right? So yeah, thanks, Darcy. Yeah, so we can look at the code example quickly. Yeah, so I have here big one. Yeah, I have here like basically I have like a soccer match going on, and there are these two websites. There is this one website which manages curating the scores, and all these other websites are subscribed to this one to get updates of the live updates of what that soccer match is, right? What the scores are, what is going on. So I have like these two websites called Soccer Sports Fans website and socceristhebest.com website, let's say. These two are observers to get notified in a timely manner about any state change, any updates to the match, right? So let's say I have like two teams, team A, that's their name, that's the score, number of fouls in the soccer match, and then we have team B, which is Liverpool, that's their score. I have defined it right now to begin with, and fouls, right? So once the soccer match subject, which is the observable here, once it has any change in the state of the game, it will update all the observers. And so these two websites, which are registered as observers, will also get notified of any change in the soccer match scores, right? And at this point, I'm also removing this observer. So when there is any change in the status of the game, so I have only one observer, so that observer will be notified right away about this change in the game, right? And at this point here, I'm updating all the observers, and we just have one, right? Because we removed the other one. So very simple implementation here. If you look at the interface again, the interface here for the soccer observer. So for the observer here, just cares about get the match scores. I only care about what the match scores are. I'm not doing anything else, right? So I'm just like subscribed to get the updates about the status of the match, and primarily, right, what the scores are. So this is what my observer cares about. So when I look at the observer here, two observers, they the data point here is match scores. That's what they care about, and they just print those match scores, right, from whatever they got from the observable. And similar with this website, this observer, it stores the match scores, and once it gets from the observable on a state change, it is just going to print that, right, that this is what this updated scores are. And I've used this printing only just for the code demo, but each observer can probably be doing more with the data points, right? Now I have my one second. Yeah, this is my match, a soccer match subject. This defines what a match or a match here is basically. So like a match looks like team A, team B, their scores and the number of fouls. I have a basic constructor, and when you get the match scores, I am just going to print the match scores that are set for this particular ongoing match. So it's very simple. This becomes like your domain object here. And my observable, this is where the core logic is, like how is my observable ensuring that, you know, it updates its subscribers, which are the observers in this case. So, so of course it stores the match scores, and then it will store a list of observers. So these become the objects that are subscribed to my observable, right? These are the websites subscribed to the soccer match observable, where a soccer match website, let's say, which is keeping a track of the scores and updating it, right, to these other websites. So what I'm doing is, this is fine. I have few functionalities here. I can always add a new observer who is interested in subscribing to get the soccer match updates. I can also remove an observer who is like, okay, I don't need to know about the status of this match anymore. And then I can, and then the update all observers. What this does is given a list of all the observers we have for this particular observable, we will update all of them with the match scores, right? With the soccer match scores, and then bunch of other methods to just getters and setters. So if you look at the initializer here, what I've done is I have defined what some basic status of the match, and then I'm making sure that these are two observers subscribed to the status of the match, and they are all updated with the state change. Let's say the state change happened and they need to be updated, right? And then one observer got removed, but in that time, the status of the match changed, the team B score got updated. So we only have one observer, and they will be notified with this new updated status, right? So that's basically the core concept, that the observers are subscribed, and on state change, observable will notify them of the updated data. So if you look here, this first observer says that the match scores are team Chelsea is these scores basically. Score is 2, number of fouls 2, Liverpool 1, and 2. The others observer also has the same status, right? Because this status got changed, all of them were notified of this exact state. Then we went ahead, this is where we notified. Then we went ahead and removed one. So we only have one subscriber, and on state of the on state change, they were notified, and now when they print, you can see that their new score is 3. But nothing else has changed because that's the only thing that got updated. Do we have any questions?
Just so I am understanding, so basically for the website is only sort of like reading what the observer says, and then for every like soccer match you create an observable class, and for every change you set the observable, which then alerts the observer, and then the website is calling a method from the observer class that gets the match updates.
Right. So here, so yes and no. I wouldn't create a new subject class. This is how every soccer match looks like. Every soccer match will have team A, their scores number of fouls, team B, their score number of fouls. Okay, so that's, let's say, somewhat standard across any kind of soccer match. But if you have, let's say you have soccer match 1 between Liverpool and Chelsea, right? This is the one. If you had another match going on, right? If you create another instance, and if you have another match going on here, and your observers can subscribe to that match too, right? So you can have multiple objects here that multiple observers can subscribe to. So that this becomes more complicated if you think about it in implementation, but that's like very much doable. Yeah, because then you have different objects that are observed by different observers, and these are separate flows altogether.
Okay. Sorry, I have one more question. I saw that soccer match subject implements observer.
Yeah.
Could you like explain why? Maybe I'm missing something.
This scores of observer?
Yeah. Sorry.
Yeah, that's fine. It implements this observer because it needs to define what the observer methods are, right? Like, what does the observer care about? Does it care about the name of the team? Then the only behavior here would be get me the name of team A or get me the name of teams. So you need to define like a common functionality between what the observers care about and how the observable is going to give you that particular functionality. So all my observers care about just getting the math scores. So my subject here is ensuring that it is able to provide that functionality which the observers are interested in.
Okay.
Yeah.
And then you could have multiple subjects depending on the matches that you have.
Sure. If you have 3 ongoing matches, let's say today between different teams, right? World Cup, whatever. Yeah, sure. And that's why we have this observer. This is also this is Java's own implementation of how internally things are, but that's why these two implement Java's observer class, but the scores, but the subject here implements this common observer functionality that sits between the observers and the observable here. So they define this contract of what the data sharing looks like, what is the observer interested in, what the observer subscribe to, right? So that the subject can publish that.
So what the observer subscribes to is the observable, which is like,
Exactly.
and then, okay.
Yeah, I could have like few more methods that here, right? I could have, like I said, like give me the like team names, something like that. I don't know, or give me like just a number of fouls, let's say, through the game. Just thinking out loud. Then my subject here needs to, it will error out because it needs to implement those methods so that my see, I have to implement them so that all my observers which are subscribed to these updates also get these updates. So I have just used one method, but if I implement these 3 methods, then all my observers will also get or will also get like basically here we'll also get all those other updates that we have now defined, right? So when you say, so here I'm just calling get match scores, but if I am calling, let's say, get fouls or get the team name, then I would also be able to, my subscribers will also get all that updates.
Okay, and your subscribers, like, I guess like you could have one observable for many matches and many like subject matches, which are like many observers, right?
Yeah, so yeah, like this observable right now only cares about one match, but like I said here, like I mentioned here, right? If I had a second match, right, then I can create, I can have different observables. I can have another observable that only cares about this second match and can have same or different set of subscribers. That's fine. That's totally fine. That's the power here. You just have, you define what that contract looks like and you can just build on top of it. And like I said, because we have an interface, I can add more functionality and I just need to add the behavior here on what that functionality should look like and make sure that my subscribers here get that data. It's as simple as that. So you can always build on top of it.
Thank you.
Yeah, of course. We have one more. Last one, which is pretty interesting too. So strategy basically helps us select one of the different strategies or algorithms or implementations at runtime, right? So it actually defines what the runtime policy, so to speak, is, right? So you can add your strategies in different separate classes, and the client, depending on what the context is, will pick one of these strategies that you have defined, right? So the way we implement a strategy is we use an interface with methods to implement what the different strategies look like, right? Like, for example, sorting. You can sort it in like merge sort, you can sort it in like selection sort, you can sort it like quick sort. You want to do sorting, but at runtime, I can determine what kind of sorting I want to do for this particular collection of data, right? Context here helps us determine what the strategy is and what its respective implementation we want to select or choose. And implementation here is just various implementations, right? Like proper implementations of this. If I choose merge sort, then I need to also code in what the implementation of merge sort here is, right? Or quick sort or selection sort, etc. Here we have like an open close principle where open means that objects are extended to select whatever strategy they want to, and closed principle here is that depending on the context, objects may not be modified. We'll take a look at this in a bit, but one real life example that we've already thought of is like sorting algorithms, right? Like whatever collection you have, list or set, you can determine what kind of sorting you want these objects to be in. If we look at the code, strategy, actually this may error out, 1 second. Here we have the strategy initializer. So yeah, so let's first look at this class. See, so I have 2 data points, and what I want to do with the 2 data points are all my different strategies or operations here, and I'm going to determine at runtime what strategy I want to implement on or what operation I want to implement on these data points. So one kind of strategy is addition. I want to add these 2 numbers. Other strategy or operation here is subtraction. The next is multiplication and division. I have the same data points, but what I'm going to do with those data points, what my implementation or algorithm or strategy here is with that data point is very different now. And with these strategy classes, I have defined what actually these strategy implementations look like. Right now, going forward, like I have an exception here where one of those numbers is 0. And if I try to multiply or divide, you cannot multiply by 0 or you cannot divide by 0. So I'm going to just print an exception here, right? So it's handling that case as well. And now if I look at, so this is my core flow or process here. If I look at the strategy class, all it does is like perform operation. I don't know what this operation is. Is it multiplication? Is it addition? Is it division? I don't know. I have not defined that. All I'm making sure is that this strategy class performs some operation on 2 data points, which are integers. That's all I have defined. Now, if you look at the implementation of these strategies, let's say multiplication, what that does is like if 2 numbers are not 0, then all it's going to do is it's going to multiply those 2 numbers and return the response. But if either of these numbers is 0, then it's going to just throw this exception that you cannot multiply by 0, right? What the division strategy does is it has its own different implementation, which is different than the multiplication operation strategy, which is it will divide the 2 numbers and return the answer of the calculation, or it will just throw an exception, right? Similar with addition in the sense that this is also a strategy, but it also performs an operation, right, from this interface. But what the behavior here is, or the implementation is different, that it does an addition of 2 numbers. And with subtraction, it just subtracts the 2 numbers for this particular operation. So we have now implemented or defined what are each of these strategies look like. Now, if I look at the the calculations concrete class, what it does is it will define a particular strategy, what I want to do, right? Like this concrete class here is a context where define a particular strategy, and depending on the strategy, I'm going to perform an operation. So if my operation strategy had few other methods here, then I would also probably be, because in interface, I would also be implementing those other behaviors from my strategy. So just because we have one method which is perform operation given 2 data points, depending on what my strategy is, addition, multiplication, subtraction, or division, it's going to perform that operation, right? So this is where we leverage the power of interfaces, and on runtime we will decide what this strategy should look like, right? So given 2 data points, the behavior or the implementation can totally be different. So if you look at our initializer class, right? So what I have done is I've created an instance of all these different strategies, and all I'm saying is perform operation, right? So what it's going to do is, given my data points, now I can actually just create instances and just run this code. And given my data points, it will implement all these different strategies based on what I have defined at runtime, right? Oh yeah, I have to fix this error here because it's not the code. Again, I should run. Yeah, so if you see here, I was able to add the same 2 numbers, right? This is my result. I was able to subtract the same 2 numbers. This is my result. I was able to multiply and then also divide. but then I changed my y to 0, so then I should get an exception, which I just got, and I just printed that exception. And the exception here was that you cannot multiply by 0 or you cannot divide by 0. So this is what like the strategy design pattern gives us the power to, given a set of data points, what you want to do on those data points can be different behaviors and different strategies around what that algorithm behavior implementation looks like. Do we have any questions? Yeah, so here, right, we have this interface and then different operations, and then our context here determines that we have to execute given a strategy, we have to execute that operation, and the initializer class just creates an instance of these strategies, and for a given data point, those strategies will be implemented. Do you have questions, comments?
That made a lot of sense. Thank you. The strategy class is definitely, at least for me, a little easier to digest than the observer.
It is. Observer can be complicated. Yes, iterator and strategy are probably most common.
Yeah.
These two. Very intuitive, easy to understand. Chain of responsibility again is a bit complicated too. But yeah, I would say depending on your domain and context, like I said, right, chain of responsibility works in a different kind of solution. If you have a PubSub method, publish, subscribe, setup, observer, observable is what you would care about. That's your way. That's your idea of design, right? That's how you would think about what your PubSub infrastructure looks like. So just to summarize, behavioral design patterns focus on these relationships and communication, right, between different classes and what their implementation also looks like. We looked at 4 of them today. First one was chain of responsibility, where between a sender and a receiver, we have this chain of objects which are responsible for processing and moving the message or the data forward in that particular chain till it eventually reaches the receiver object. Right, iterator, very simple. It helps us traverse through a collection of objects in a manner that we define. Right, we can traverse the same collection in multiple different manners. Observer is a one-to-one dependency between objects. So a state change of one object will be communicated to all the other objects that are subscribed to this particular state change for this main object. Right, so state change of observable, all the observers will that are subscribed or registered will get notified. Strategy is select one of the different strategies for the data points at runtime. Our next section is in 2 weeks, where we talk about anti-patterns. So this is somewhat the end of design patterns, where these are best practices or template solutions to solve some common problems that we build on top of. Right, anti-patterns are things that are considered bad practices or things that we should not be doing, and why it's so easy to, when we try to solve a design problem, we get into an anti-pattern and we get stuck till we realize that actually this is probably not the best way to do it. So they help us. Anti-patterns, if you understand what they are, they protect you from not making the mistakes that you might end up doing as you're designing. Right. Again, I'm just sharing the resources. This presentation and the code demo is on GitHub. We have a YouTube channel where we have basically a playlist of all the videos from our first session, second, third session, fourth session, and this session's video will also be uploaded in few days. I have used these references for this whole design pattern mini series. And if there's something more, I will update it in the deck here. Again, you can find this deck on GitHub. Yeah, thank you. Do we have any questions? Aditi, can you share the feedback form?
Right now,
Yeah.
we can send it in the email. Is
Yeah,
that's what
yeah,
how?
channel 2. Yeah. Channel 2. Yeah. If Anjana, if you have like any feedback, or if there are certain topics you want us to look into or talk about in any of the upcoming sessions, like feel free to give us just in the backend study group channel. Feel free to post or ping me or Aditi, and we'll try our best to create sessions.
Yeah,
around.
definitely. Thank you so much for, like, I guess, hosting this session. I always learn a lot, so I appreciate it.
We might have a design, system design one. So yeah.
Oh my gosh, I would love that. Sorry, I think you froze for a second, but I heard design. So
Design.
yeah, that would be awesome.
I know, yeah. The more you learn about system design, you realize there is so much more.
Yeah.
So yeah.
Something that I think would be really cool is like, and we did this, and I went to another Women Who Code session. It was algorithms and data structures related. They had like breakout groups where people would like basically like solve a problem together. I think that'd be really fun to do with systems design, because that's like, it really mimics like a real world setting. But like I, for example, haven't really had the opportunity to like, you know, fully dive into a systems design problem. So having a space to do that would be really cool.
Yeah. Yeah, we understand that, and I agree with you. The fifth session in this mini series is actually interview questions, where we will not only like discuss the theory of some very common design pattern questions, but we will also look into coding. And I'm trying my best for that session to be hands-on. So wherever the participants are, we can just come up with a question, and how would we go around solving it, right? How would you code it? Do it in Python, do it in Ruby, do it in Java, whatever your preference is, however you understand it. But it would be really cool to like actually code these problems and share in the session.
Yeah, I would love that.
I found this website for design patterns, which has like implementations in various languages.
Yeah, it's there in the source here. Yeah, but I'll share it in the we can share it in the channel too.
In the channel, yeah, I was thinking I'll just share it in the channel because I know many of them have asked for Python implementations as well.
Yeah, for sure. Yeah, we can do that, and I'll find some other resources in other languages too, and share it in the Slack channel.
And then the recording for this also, we can share it in the Slack channel as well.
Good point. Yeah. Once we get it, we can just post it.
Yeah.
I'm so sorry, I have to hop off, but thank you so much.
Yeah, thank you.
Thank you.
Thank you. Bye.
Bye.
Stop the recording.